Bismillahirrahmanirrahim. In our previous lecture, in which we have discussed about the equipment economics, fundamental concepts of equipment economics, and different concepts related with the interest, this lecture is the continuation of our previous lecture, and we will discuss more about the concepts of equipment economics. In our previous lecture, we have tried to answer two basic questions related with the equipment economics. The first one was that how much does it cost to operate the machine on a project? The second question was that what is the optimum economic life and optimum manner to secure a machine? We have discussed about equipment record, how we can maintain the equipment record. We have discussed about the time value of money. Similarly, we have seen different concepts of equivalence, like how different values are equivalent to each other but not equal. As the concept of equivalence or the equivalent depends on time and also the interest rate applied on that. We have seen the equations for single payments and different formulas for uniform series of payments. We have also discussed about the cash flow diagrams in our previous lecture, and we have also solved different examples related with the simple interest, compound interest, and then with the uniform payment. So in today's lecture, we will start with the cost of capital. And in this lecture, we are going to discuss the discounted present worth analysis and different elements of the ownership cost and different elements of the operating cost. Then we will also discuss about the depreciation in a bit detail. So starting with the cost of capital. In economics and accountings, it is the minimum rate of return that a business must earn before generating value. Like a project is not being operated, is not being started until now, but how much the minimum return it will give back. Before a business can turn a profit, it must at least generate sufficient income to cover the cost of the capital it uses to fund its operations. This consists of both the cost of debt and the cost of equity used for financing a business. The concept of equity we will discuss in our next slide. A company's cost of capital depends basically to a large extent on type of financing the company chooses, its capital structure. The company may rely either on solely on equity or solely on debt, or use a combination of both. The cost of capital interest rate a company experience is affected by the risk associated with its business type. Like what kind of the risks are associated? The market perceives the risk of business and applies an after-tax discount rate to the future wealth it expects to deliver from this firm. It can also be used to evaluate the new projects for a company. There are three basic parts. The first is debt, how much is being borrowed. The second is equity, like the sale of the stocks. In finance, equity is the ownership of assets that may have debts or other liabilities attached to them. Equity is measured for accounting purpose by subtracting the liabilities from the assets. So in this figure, you can see that we have assets and the liabilities. So the subtraction of the liability from the asset, we get the equity. Like we have the assets, a building, a car, or some other equipment which may have any worth, and we have many liabilities like debt or other kind of liabilities. So if we subtract the worth of the liabilities from the assets, we get the equity. Similarly, the third part is retained earnings, or we can say internally generated funds. So now coming towards the evaluating investment alternatives, there are different alternatives. The purchase, rental, or replacement of a piece of equipment is a financial investment decision. And as such, the real question is how best to use a company's asset. Financial investment decisions are analyzed using time value of money principle. Such analysis usually require an input interest rate or calculation of the interest rate that result from the assumed cash flows. So the financial investment decisions are analyzed using the time value of money principle, which we have already discussed. So now coming towards the discounted present worth analysis. A discounted present worth analysis involves calculating the equivalent present worth or the present value of all the dollar amounts involved in each of the individual alternates to determine the present worth of the proposed alternates. So basically, this statement tells us that we are going to calculate the equivalent present worth of different alternatives. Similarly, as we have discussed in the decision making analysis, like we have to evaluate different alternatives and then we have to decide which alternative is the best or which is having a least cost. We will also solve an example on this discounted present worth analysis, so it would be more clear how this thing works. The present worth is discounted at a predetermined rate of interest, often termed the minimum attractive rate of return, or we can say it MARR, minimum attractive rate of return. Like what will be the minimum attractive rate of return which we can use and calculate the present worth. The MARR is usually equal to the current cost of capital rate for the company. So now we will use an example and see how this discounted present worth analysis works. So we have solved three examples before. So this is the fourth example for this topic. For example, a builder is considering three different acquisition methods for obtaining pickup trucks. Like he has three different alternatives, so he has to choose by making the discounted present worth analysis which option is the best one for that builder to choose, as he has to get the pickup trucks. The first alternative is that immediate cash purchase trucks for $16,800 each. Like he can purchase each truck on the cost of $16,800, and after 4 years sell each truck for an estimated $5,000. He can purchase for the amount of 16,800 and can sell after the 8 years at after the 4 years at the cost of $5,000. So this is the present worth 16,800. 4 years is n, the duration, the time period, and this one we can say the salvage value, the end value on which he can sell the trucks. The second option, let's see. The second option states that he can lease the trucks for 4 years, for 4,100 per year paid in advance, 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 4,100 per year paid in at the beginning of each year. Like in each year, he can pay 4,100 for each truck, and in the beginning of the year for 4 years time. The contractor pays all the operating and maintenance cost for the trucks, and the leasing company retains the ownership. In this case, this builder does not have the ownership, so he can lease the truck for 4 years. For each year he has to pay $4,100 in advance before the beginning of the year, and all the operating and maintenance costs he has to bear. This builder has to bear. So this is the second option. So the third option is that purchase the trucks using a time payment plan requiring an immediate down payment of $4,000. Like he has to immediately pay 4,000. In this case, it was 16,800. In this case, he has to pay $4,000 and 4,500 per year at the end of each year for 3 years. So he has to pay 4,000 initially, the down payment, and 4,500 per year at the end of each year for 3 years. Assume the truck will be sold after 4 years for 5,000 each. So these are three different scenarios. In this case, he has to pay all the amount in advance. Like for one pickup truck, its cost is 16,800, but after 4 years he can sell it on $5,000. In the second case, he has to lease the truck for 4 years, and every year in the beginning of the year he has to pay $4,100, and he doesn't have the ownership. The leasing company which is giving it on the lease retains the ownership. The third case was that he has to pay the 4,000 immediately and then 4,500 per year at the end of each year. But not the beginning. In this case, he has to pay in the beginning of the year. But in this case, he has to pay at the end of each year for 3 years. And at the end of the 4 years, that truck can be sold for 5,000 each. So similar as in this case, 5,000 it can be sold, and in this case also the 5,000 it can be sold. So in this case, the question is basically, if the contractor MARR, the minimum attractive rate of return is 8%. If it is 8%, which alternative should be used? If the minimum attractive rate of return is 8%, so which alternative the contractor should be using? So to calculate the net present worth of each alternative using an 8% interest rate and select the least costly alternative. So what we have to do, for all these cases, we have to find the net present worth using 8% interest rate, which is minimum attractive rate of return. So I hope you have understood the question. So now let's move towards its solution. So for the alternative A, we have to use the present worth compound amount factor to calculate the equivalent salvage value at time 0. We have to add the purchase price, which is negative because it's a cash outflow. As we have discussed in our previous lecture, the purchase price is a negative cash flow. However, the salvage value, the equivalent salvage value, is the positive cash flow. So as we have seen in the cash flow diagram, all the negative cash flows are uh, downwards and the positive cash flows were upwards. Sorry, all the positive cash flows were upward and all the negative cash flows were downward, which we have seen in the cash flow diagram. So in case of the alternative A, the net present worth we have to find out. So net present worth we can find out by 16,800 because this is a negative cash flow. So 16,800 because 16,800 is the immediate cash which this person or the contractor has to pay. However, this 5,000 is the salvage value, the value which will remain at the end, but this will be after 4 years. So we have to find out how much this 5,000 is, its worth is right now, how much this 5,000 is right now. Like for example, it is 2,000 right now, and after 4 years it will become 5,000 or what. So we have to calculate it by dividing it with our formula for the net present worth. So here we have to divide this 5,000, the salvage value, which will be after 4 years, with present worth compound amount factor. So present worth compound amount factor, if we refer to our equation equation B, so this is the future value F, and this is 1 plus I, the interest rate, whole power n. So solving this equation, here I is 8% or 0.08, where n value is 4 years, because there are 4 years and minimum attractive rate of return is 8%. So we have to put the value. So if we put 1 and 0.08 power 4, so we get 1.36. So dividing 5,000, which is the future value F or the salvage value at the end of 4 years, with this formula we get 13,124. So this value we get. Similarly, now we have to calculate for our alternative B. For alternative B, as there is no salvage value in this case, as the leasing company retains the ownership of the truck. As we have discussed in our alternative B, that he has to pay 4,100 US dollars in advance of each year. However, he does not have the ownership of those trucks, but the ownership would be with the leasing company. So for alternative B, we have to use the uniform series present worth factor to calculate the time zero equivalent value of the future lease payments. As in future we are going to pay, for example, in the beginning we have to pay 4,100, and then after 1 year, in the beginning of the second year, we have to pay 4,100. So we have to calculate how much those 4,100 which we are going to pay in the later years has worth right now. So, and we have to add the result to the value of the initial lease payment. Both of these are negative because these are cash outflows. These are going out of the company. There is no salvage value in this case, as the leasing company retains the ownership of the trucks. So this formula we are going to use. As $4,100 we have to pay right now. This is the present worth because we are paying it at this moment initially, and these 4,100 we are paying at the beginning of every year. So we are going to use uniform series present worth factor. So using this formula, in this we have the I value. I is 0.08 or 8%, and N is, we will use N as 3, not 4, because it will be only for 3 years, not for the 4 years, because 1 year we have already put the value here. So this N would be 3, not 4. So here we will also put the 0.08 or the minimum attractive rate of return. Here it's written wrong, I'm sorry for that. So N is equal to 3, not 4. So we get this value as 14,666. So 14,666. So as the payment is in the beginning of the year, so N value will be taken as 3. This is wrong, not. So we will use it as 3. So N would be 3, not 4. So now coming towards so we have calculated this. So this is the net present worth of the alternative B. So now let's calculate the net present worth of alternative C. If we have seen that in the third case we have to immediately pay $4,000, and then we have to pay 4,500 per year at the end of each year for 3 years, and 5,000 would be the salvage value. So we have to add the three values: the initial payment, the equivalent annual payment, both being negative, and the salvage value being positive. Salvage value is positive because that is a cash inflow, so that's why it is positive. To arrive at the at the net present worth of the alternative C. For alternative C, we have to use the uniform series present worth factor to calculate the time zero equivalent value of the future payments, and the present worth compound amount factor to calculate the equivalent salvage value at time zero. There we are going to use two different formulas. The two formulas which we have used for calculating the alternative A and B, we are using both of those factors. So we will use the uniform series present worth factor to calculate the time zero equivalent value of the future payments, like the future payments which we are going to make, the 4,500 each year at the end of each year. And for the salvage value, we are going to use the present worth compound amount factor. Then we have to add the three values: the initial payment and the equivalent annual payment, both are negative, and the salvage which is positive, so that we can calculate the net present worth of the alternate C, that how much worth or how much money we have to pay if all these values are taken back to today's, the present worth. So we are going to use this formula. This 4,100 is that which we have to pay initially. This is 4,000, sorry, this is not 4,100, this is 4,000 which we have to use in the beginning. So this is 4,000 which we have to pay in the beginning, and then 4,500 which we have to pay each year for 3 years, at the end of each year for 3 years. And this is the salvage value. So the salvage value is 5,000 at the end of 4 years. So how much worth it has right now, and this we have to pay after 3 years. So how much worth it has right now. So for using the uniform series present worth factor formula, this is the formula which we have to use, as this is the future value. Here this is the future value and this is the present worth compound amount factor. So by just putting the values, we will use as the minimum attractive rate of return, which is 8%, or we can say 0.08. And here we are going to use 3 because this is for 3 years. Here we are going to use I as 0.08 and N as 4, because the salvage value is for 4 years. However, this value we are going to use for 3 years. So if we put values in this 0.08 and in this we put the 3, so we get this value 0.2597 divided by 0.100. So we have to divide this and multiply by with 4,500. Similarly, for the salvage value, we have 5,000 value and we have to divide it with 1.36, which came from 1 plus 0.08 power 4. So now we have to simplify this equation. So we get 11,921. So this is the net present worth for the alternative C. So now we have calculated all the alternatives for A, B and C. So now let's see this. So for the alternative A, the cost was 13,124. This is the cash outflow. So for the second, it is 14,666 cash outflow. That's why it's negative. For the third one, it's 11,921. So in all these, which one is less? The alternative C. So if we have to pay at the present, related with the present, so we have to pay 11,000 if we choose alternative C. However, if we choose alternative A, we have to pay 13,000. If we choose alternative B, we have to pay 14,666. So the least costly alternative is C. So through this method, the discounted present worth analysis method, we can calculate which alternative is the best one or the least cost alternative which we can use in our problems. The example which we have seen was simplified in two respects. The first one was that the number of the calculations required were quite small. The second, that all three alternatives involved the same time duration, that is 4 years in this example. There can be problems which involve more data and may require more calculation, but the analysis approach is same as we have done in this. When the alternatives involve different time duration, for example, machines have different expected durations of the usefulness. Maybe some machine have 3 years and some have 4 years, or so on. The analysis must be modified to account for different time duration. Obviously, if a comparison is made of one alternative having a life of 5 years and the another with a life of 10 years, the respective discounted present worth are not directly comparable. However, how is such a situation can be handled? So there are two different approaches which are generally used. The first approach is cut off the longer lived alternatives to equal to the shorter lived alternatives, and we have to assume a salvage value for the unused portion of the longer lived alternatives. Then we have to make the comparison on the basis of equal lives. The second approach which can be used is that we have to compute the discounted present worth on basis of the least common denominator of different alternatives lives. So we can also adopt this method. So these two approaches can be used if we have different lifespans for the equipment. Now we will discuss different elements of the ownership cost. Most of the ownership cash flows are expenses, but a few are also cash inflows. One of the most significant cash flows affecting ownership cost are purchase expenses, salvage value, which we can say it's a cash inflow. The purchase expenses are always cash outflows or the expenses. Tax savings from depreciation, major repairs and overhauls, insurance, storage and miscellaneous. These are different cash flows, which can be some of them are cash outflows and some are cash inflows. The first one is the purchase expense. The cash outflow the firm experiences in acquiring ownership of a machine is called the purchase expense. It is the total delivered cost or the drive away cost, including amount for all options, shipping and taxing, also less than the cost of the tires if the machine has pneumatic tires, because the pneumatic tires are usually um, used within 2 or 3 years, or depends on the work which the equipment is doing. So it is being subtracted from the original cost, because this is a repetitive expense. The machine will show as an asset in the firm's accounting records. The firm has exchanged money, a liquid asset for a machine, or a fixed asset with which the company hopes to generate profit. As the machine is used on projects, wear takes its and the machine can be thought of as being used up or consumed. This consumption reduces the machine's value because the revenue stream it can generate is likewise reduced. In the initial time, or when the new machine is bought, it can be more productive and it can generate more value than in the later years, 2 or 3 years later, because it is less productive and it has more expenses. Normally, an owner tries to account for decrease in value by um, prorating the consumption of investment over the service life of machine. The prorating is also known as depreciation. So the second um, element of the ownership cost is salvage value. Salvage value is the cash inflow in a firm's receive if a machine still has value at time of its disposal. When we are going to dispose of the machine, so what kind of or what worth it has. This revenue will occur at a future date because this will be occurring when we are not going to use machine anymore and we are going to sell it or dispose it of. Used equipment prices are usually difficult to predict. It's not easy that how we can predict what value this excavator or this boiler or any other equipment would have after 3 years or 5 years. It is a tricky question and it is difficult to predict. The movement of new machine prices and the machine's possible secondary service applications affect the amount an owner can expect to receive. A machine having a diverse and layered service potential will command a higher resale value. If a machine has the diversity in application, so it has higher value at the end. Medium-sized dozers, which often exhibit rising salvage value in later years, can have as many as 7 different levels of useful life. These may range from an initial assignment as high productive production machine on a dirt spread to an infrequent land clearing assignment by which can be used by the farmers. So these kind of dozers can have multiple tasks which they can do. When they are really highly productive, they can be used for dirt spreading, but when they are not that much productive, they can be used for the land clearing. Historical resale data can also provide some guidance in making salvage value predictions and can be fairly easily accessed from the auction price books. Every company has the auction price books or through their accounting details that for how much they have sold the equipment previously. By by studying such historical data and recognizes the effects of economic environment, the magnitude of salvage value prediction errors can be minimized, and the accuracy of an ownership cost analysis can be improved. The third one is the tax savings from the depreciation. The tax savings from the depreciations are a phenomena of the tax system. Depreciating machines' loss in value with age will lessen the net cost of machines ownership. It can also be used in the tax system of Pakistan. If you can go to the FPR website, you can also see this tax saving from depreciation. They have a full-fledged policy how the tax can be saved from the depreciation of a asset. The cost saving, the prevention of cash outflow afforded by tax depreciation is a result of shielding the companies from taxes. So this tax depreciation shields the company or provides a cushion for a company from the taxes so that they have a low tax slab instead of higher tax slab. This whole is only applicable if the company is in profit. If the company is in loss, so this is not applicable. So usually um, the rate at which the depreciation of a machine occurs are set by the revenue code, and these rates usually have no relation to the actual consumption of the asset. Maybe the equipment or the asset is consumed less, but the rates are higher, or vice versa, or it can be otherwise. The tax saving from the depreciation are influenced by disposal method for the old machine and the value received for the old machine, and also the initial value of replacement, its class life, tax depreciation method which is being applied. Based on the relationship between these elements, three distinct situations are possible in this scenario. The first one is no gain on the disposal, no income tax on zero gain. The second one is a gain on the disposal. When you dispose that equipment, you are going to get a gain or get some value out of it, money out of it. So the like kind exchange, no added income tax, but basis for the new machine is adjusted when there is a gain on the disposable on disposal. The third party sale, the gain is taxed as income. The basis of the new machine is fair market value paid. The third one is a disposal in which a loss results. Uh, the first one was that no gain, no loss. Um, the second one is gain on disposal. The third one is a disposal in which a loss results. The basis of this, the new machine is same as the basis of the old machine, decreased by any amount received. So the fourth one, this tax depreciation, we are not going to discuss it in more detail, but we are going to discuss the next point, which is major repairs and overhauls. This depreciation we will be discussing in the ownership cost as well in our future slides. Major repairs and overhauls. Major repairs and overhauls are included under ownership cost because they result in an extension of machine's service life. Because the more you are putting an effort to repair your machine and keeping it in a good condition, it extends the machine's service life. Similar is the case if we are not going to have the overhauls or repairs of the machine, its service life can be decreased. So they can be considered as an investment in a new machine because a machine commonly works on many different projects. It is working on various projects. Considering major repairs as an ownership cost prorates these expenses to all jobs. These costs should be added to the basis of the machine and depreciated. The fifth one is the insurance. Insurance includes the cost to cover fire, theft, damage to the equipment. Uh, the annual rates can be very, it depends on the company, the type of services they are providing, and what kind of things are included in the insurance policy. So it can vary from 1 to 3%. This cost can be actual premium payments to insurance companies, or it can represent allocations to a self-insurance fund maintained by equipment owner. The sixth one, the ownership cost is storage and miscellaneous. Because when we have equipment or any other machinery, we also have to store it somewhere. When it's not working, uh, during the project when it's working, so it's fine. But at some point, when there are no projects or there's some gap between different jobs which have to be done, so these equipment need to be stored. So between the jobs or during bad weather, a company will require storage facilities for its equipment. The cost of maintaining storage yards um, and facilities should be prorated to those machines that require such harborage. Typical expenses include typical expenses for the storage include rental, utilities, and the wages for the laborers or the watchmen. Usually, these expenses are all combined in an overhead account and then allocated on the proportional basis to individual machines. The rate may change from nothing to perhaps or usually 5%, because maybe the contractor or the company has its own storage facilities, and they have their staff which are looking uh, for the equipment, or maybe they don't have any such facilities. So in those cases the cost can be higher. So now we have discussed different elements of ownership cost, which um, included purchase expenses, salvage value, tax saving from depreciation, major repairs and overhauls, insurance and storage and miscellaneous. These things are the ownership cost. But now let's see what are the operating costs. The first one were when we are owning an equipment, when we have an ownership of an equipment, so what type of cost we have to bear, or what type of expenses or the elements it has. But now when we are operating that machine, so what elements does the operating cost have? The operating cost is the sum of those expenses and ownership and an owner experiences by working a machine on a project. The typical expenses include fuel, uh, lubricants, filters, and grease. Similarly, the minor repairs, tires, and replacement of high wear items. If you remember, we have subtracted the tires from the um, ownership cost of the purchase equipment, because we have said that these have high wear and tear, and these are to be replaced. So these are included in the operating cost. Operator wages, the operator which are going to operate the equipment, are sometimes included under operating cost, but because of the wage variances between project, the general practice is to keep operator wage as a separate cost category. So it is not included in the operating cost, but uh, taken as a separate category. Such a procedure aids in estimation of the machine cost for bidding purpose, as the differing project wages, um, wage rates uh, can be added to the total machine operating and ownership cost. In such cases, some benefits are based on an hourly basis, some on percentage of income, some on percentage of income to a maximum amount, and some are paid as fixed amount. The assumption about project work schedule will therefore affect the wage expense. So the first one, now we are going to consider the fuel. Fuel expense is usually best determined by measurements on the job. Accurate service records show the owner that how many gallons of the fuel a machine consumes over what period of time and under what job condition. Hourly fuel consumption can be calculated directly. So different machines consume different amount of fuel on the same job. Similarly, they have different fuel consumption if the job condition is changed. For example, an excavator is consuming 5 gallons per hour in the normal condition, when the strata is not that much difficult. But in other cases, if there is not a planned strata or having different job site condition, it can consume more than that 4 or 5 gallon. So these fuel consumptions can be taken from the company's record, but when the company records are not available, manufacturer's consumption data can be used to construct fuel use estimate at how much fuel would be used, because the manufacturer of that equipment also provides the fuel consumption. The amount of fuel required to power a piece of equipment for a specific period of time depends on the brake horsepower of the machine and the specific work application. Fuel consumption can be calculated on a theoretical basis. Uh, the resulting theoretical values must be adjusted by time and load factors that account for working condition, that what kind of working condition it has. This is because the theoretical formula are derived assuming that engine is operating at maximum output, and working conditions that must be considered, or the percentage of an hour that the machine is actually working. This is the time factor, that the percentage of an hour the machine is actually working is also known as time factor. And at what percentage of rated horsepower, or we can also say it throttle load factor, uh, when when operating under standard conditions, a gasoline engine will consume approximately 0.06 gallon of fuel per flywheel horsepower. So the second operating cost, or lubricants, filters, and grease. The cost of lubricant oil or filters and grease will depend on the maintenance practices of the company and the condition of the work location. That what are usually the practice of the maintenance? Are they going to have maintenance after every project, or after every 3 months, or after every 6 months? So these filter grease and lubricant oils, etc., depends on the maintenance practices of a company. Some companies usually follow the machine manufacturer's guide concerning time period between lubricant and filter changes. They can have um, a guidance from the um, manufacturing companies that after every 1,000 working hours you have to change the lubricant or filter. um, and some other companies have established their own preventive maintenance change period guidelines, that what is the minimum time, or what is the maximum time when we have to change the lubricant and the filter and the other grease. In either case, the hourly cost is arrived uh, by these two things, by considering the operating hour duration between changes and the quantity required for a complete change, plus a small consumption amount representing what is added between these changes. So in each case, or whatever the case is, the hourly cost is usually got through this procedure. A formula can be used to estimate the quantity of oil. So this formula on your screen, you can see this can be used. So here HP, you can see HP is the rated horsepower of the engine, what type of engine it has. C is the capacity of crankcase in gallons, this C. The F is operating factor. T is number of hours between oil changes. So this formula contains the assumption that the quantity of oil consumed per rated horsepower or between changes will be 0.06 0.006 pound. So the third, the first of the operating cost we have discussed is fuel. The second of the operating cost is lubricant or lubriles or filters and grease, etc. The third operating cost is repairs. These are normal maintenance type repairs, and these repair expenses can be done during the on the job site where the machine is operated and would include the cost of parts and labor. Major repairs and overhauls are an ownership cost. Repair expenses increases with the machine age. The the new machines doesn't have much repair cost, but as the machines get old, their repair cost also increases or gets higher. The fourth one is tire. The tires for wheel type equipment um, are a major operating cost because they have a short life in relation to iron of a machine. If you see the whole body of a machine and the tires, if they are pneumatic tires, so they have less life, which are which have to be changed. Tire cost will include repair and replacement charges. Tires can be repaired or these can be replaced. These costs are usually very difficult to estimate because of the variability in tire wear with the project site condition and operator skill. So it depends on two things: the project site condition, as we have discussed earlier, that what kind of site condition that project have, and the other is operator skills. So these costs vary with these two conditions. Both tire and equipment manufacturers publish tire life guidelines, which are based on tire type and job application. So these tire life guidelines are published based on tire type and the job application where they are going to be used. So the manufacturer's suggested life period can be used with local tire prices to obtain an hourly tire cost. So they have given the manufacturer have given the life period, which can be used with the tire prices to obtain the hourly tire cost. However, it it must be remembered that the guidelines are based on good operating practices, and these doesn't include abuses such as overloading haul units, as um, as the as the original cases. If we see some truck, if um, if a company buys some trucks, so they overload it usually, so that they can so so that the uh, the higher uh, so that they can obtain the higher productivity in the initial time, but it affects the overall structure or overall condition of the equipment or that truck with the passage of time, and it becomes it has low salvage value at the end. So the fifth cost, which is included in the operating cost, is replacement of wear items. So sometimes the equipment have cutting edges or repair tips or bucket teeth, which or cables which have to be replaced. So by using the past experience or the manufacturer life estimates, these costs can be calculated and then can be converted to the hourly basis, that how much the hourly cost will be. So these can be calculated per working hour, and it is very easy to sum all the applicable costs for a particular class of machine. So, as we have discussed, so there are five operating costs which we have discussed until now. The first one was fuel. The second one was lubes or lubricants and grease and oil. The third one was repair, the minor repair which can occur with the passage of time. The fourth one was tires replacement, and the fifth one is the replacement of high wear items. So in the cost of bidding, we have different costs. The two basic costs are the ownership cost and the operating cost. But here we are going to discuss only the ownership cost. Um, the process of selecting any type of machine for use in a project requires a deep knowledge of costs associated with operating the machine in the field, and also the unit production rate, at which rate this machine will work. These costs can be used for the project bidding and the cost accounting. So here we are interested in both ownership cost and the operating cost. Ownership and operating costs are usually expressed in any amount per hour, per operating hour when the equipment is operating. So the first one, we are going to see the ownership cost, and we will discuss its depreciation with the passage of time. The ownership costs include the expenses of the purchasing the machine, the initial expenses which are being used, and then the inflow of the money. So here we will also discuss the depreciation, and we will also solve some problems related with this. So the first one is that the depreciation is measuring system which is used to account for purchase expense at zero time, because the zero time we are saying when we are buying the equipment, and the salvage value after a defined period of time. For example, the equipment life is 5 years. So what worth it has right now at zero time, and what worth will it have after 5 years? So just subtracting these two, so we get the amount on which the depreciation is applied. Here we have to know that depreciation, in the actual depreciation which is being held or occurred on the equipment, is very much different from the tax depreciation which we have seen in our previous slides, because the tax depreciation, there are set formulas or the guideline from the government that how much an asset would depreciate. However, that cannot be the actual case in reality. So the first thing in ownership cost depreciation is the first method we can say is depreciation time value method. The time value method will recognize the timing of the cash flows, that the purchase at time zero and the salvage at future date. The cost of in this case we can say the cost of the tires is deducted from the total purchase price, uh, which includes amounts for all options, shipping and taxes, etc. A judgment about the expected service life and corporate cost of the capital rate are both necessary parameters in this analysis. So now we will also have an example on this time depreciation method. So here the question is that a company having a cost capital rate of 8%, or we can say the interest rate of 8%, purchases a $300,000 loader, loader than equipment, The machine has an expected service life of 4 years, N is 4 years, and will be utilized 2500 hours per year. So this equipment, this loader will be used 2500 hours per year, and its initial cost is $300,000 with a capital rate of 8% for 4 years. The tires on this machine cost $45,000. The estimated salvage value at the end of 4 years is $50,000. So $50,000 is at the end of 4 years, and this is the cost of tire. So we have to calculate the depreciation portion of the ownership cost for this machine using the time value method. So here first we have to subtract the cost tires because cost of tires, because this method says that we have to deduct the um, cost of tires from the total purchase. So the purchase price less than the tires is $255,000. So now we have to calculate the equivalent uniform period series required to replace the present value of um, 255,000 $255,000. So we have to use our equation F, which we have discussed in our previous lecture. Here we have this value of P. So we are going to annualize it, like how much per year this cost would be. If we are, this is the present worth, the present value. So how, if we are going to convert it into annual cost, so what would be that? So this P is going to be 255,000. The I, we already know that it is 0.08 or 8%. So just we have to put values in this formula. In this formula we have to put the values as the N is 4, because it is for the 4 years, continuously for the 4 years. So we can get the value of A. So just simplifying this would be 0.3019, which we have to multiply with this. So we get 76,000 and $990 per year. So we have to, this is the annualized value. So now we have to calculate the equivalent uniform and period of investment that equals to the future salvage value. This came from the purchase value per year, but now we are going to calculate the salvage value annualized period. So we are going to use this formula. Here F we already have. It is the salvage value, which is 50,000. I is 0.08 and N is 4 years. So we just have to put all the values number in this and simplify it, which comes out to be 0.022 multiply with the 50,000. So the annual salvage value would be $11,096 per year. So here we have the purchase, annualized purchase, which would be negative because that's the cash outflow. However, the salvage value would be positive as it is the cash inflow. So using the time value method, the hourly depreciation of the machine we can calculate by this formula. We just have to subtract both, as this is subtract both and divide by 2500, or we can say we can put the negative sign here and positive sign with the salvage value. So that's the same case, and we can get 26 dollars, $26.358 per hour. So this is the per hour operating cost which we have got through this time value method of the depreciation. So the second method is of the depreciation calculation is average annual investment method. In this second approach, we have to calculate the depreciation portion of the ownership cost at the average annual investment. So we are going to use this formula for the average annual investment, where in this formula the P is the purchase uh, price less the cost of the tires, as we have done in previous case, and S is the estimated salvage value. This is the salvage value. So this is the purchase price less the cost of tires. N is the expected service life. So in this case, the average annual investment is multiplied by the corporate cost of the capital rate to determine the cost money of the depreciation. The straight line depreciation of the cost of money uh, of the machine is less the salvage and less the cost of tire if pneumatic tires machines is used. So on the same formula, we are going to solve. On this formula, we are going to solve the previous examples which we have done. So this is example 6. Using the same data which we have adopted for time value method, we are going to use the same data for and calculate the depreciation through this method. In this case, we have same like 8% of the annual the capital rate uh, and 300,000 the purchase cost and 2,500 or use per year the operating utilization is, and the machine tires are $45,000 dollar, and the 50,000 is the salvage value here. So now using the so now we are going to use the average annual investment um, method equation. So just we have to put the value of P which is less than the tires, which is 255,000. 4 is number of service years which we have put. S is the salvage value, N is the service, and N is the service. So just putting all these values in here and simplify. So average annual investment is one 178,125 dollars per year. So the cost of the money of the portion in this for the per year, how much it will come. So we have to multiply it with the 8% of the capital cost and divide it with the 2,500 or per year. So this value comes out to be um, $5.7 per hour. So now we are going to use the straight line depreciation. The initial cost was 300,000. The cost of tires is 45,000. The salvage value is 50,000. So we have this value. The total value remain is um, as we are subtracting this and also salvage value we will have. So subtracting all these from the initial purchase, the value comes out to be 205,000. So just for the 4 years straight line depreciation, if we say that how much this cost would depreciate over the, how much this value would depreciate over 4 year times. So what we will do, we'll divide it by 4 years, but as we have to calculate per hour, so we also have to multiply it with 2,400 hours, 2,400 hours per year. So dividing this cost, which is less than the cost of tires and less than the cost of the salvage value, we are going to divide it. So per hour cost we can get, which is 20.5. So in this method we have to add up both the cost of money portion plus the straight line depreciation. So we have to add up both, so we get $26.2 per hour. So with this average annual investment method, we get the value of $26.2 per hour. So in example 5 and 6 which we have done, if we subtract both, this was the cost for the time value of money, and this is through the average annual investment method. So the difference is $0.158 per hour in the ownership cost. The choice of which method to be used is strictly depends on the company's preference. However, all the analysis should use the same method. Basically, either method is satisfactory, especially considering the impact of the unknowns concerning service life, operating hours per year, and expected future salvage. So there is no single solution to calculate ownership cost. The best approach is to perform several analyses uh, using different assumptions and to be guided by the range of solution. If we have range of solution, then we can choose uh, which is the best one. So there are also operate. We have seen the depreciation and the related ownership cost. So similarly, we also can have the operating cost, and the similar type of analysis can be done. So based on these two operating and operational cost, the ownership and operating cost, the replacement decision can be made, that when the equipment should be replaced. So a piece of equipment has basically two lives: a physically limited working life and cost limited economic life. As until when the equipment can work properly. The second is cost limited economic life, like how the equipment is able to work, however it is not able to work economically. So we have to see both things. Maybe it is working economically, but it is not working, it is not able to work physically in a good manner, or in a more productive manner. So we have to see both things, because the equipment owner or in business to make money, the economic life of their equipment is of critical importance. A machine in good mechanical condition and working productively enjoys a strong bias in favor of its retention in the equipment inventory. The Usually the equipment manager may look only at a high initial cash outflows associated with the purchase of a replacement machine, and consequently ignore the other cost factors involved. All cost factors must be examined when considering a replacement decision. So we have to consider all these costs: operating costs, the ownership cost, before the replacement of an equipment. So if we are going to secure a particular type of machine, there are three different methods. Uh, as we have discussed in our first lecture, that the equipment can be we can buy the equipment direct and it has direct ownership. The second one is rent, and the third one is lease. Each method has its own advantages and disadvantages. However, the ownership guarantees control of machine availability and the mechanical condition, but it requires continuing sequence of the projects to pay for the machine. The ownership may force a company into using obsolete equipment, as they don't have the new equipment, but as they own obsolete the old equipment, they have to use it. So the calculations applicable for determining the cost of direct ownership shift have to be developed based on all these things. So this is it for the today's lecture. Thank you for listening, and good luck.